When you're learning a new idea, for example, a new vocabulary word, or a new concept, or a new problem-solving approach, you sometimes tend to practice it over and over again during the same study session. A little of this is useful and necessary, but continuing to study or practice after you've mastered what you can in the session is called overlearning. Overlearning can have its place. It can help produce an automaticity that can be important when you're executing a serve in tennis or playing a perfect piano concerto. If you choke on tests or in public speaking, overlearning can be especially valuable. Did you know that even expert public speakers practice on the order of 70 hours for a typical 20-minute TED Talk? Automaticity can indeed be helpful in times of nervousness. But be wary of repetitive overlearning during a single session. Research has shown it can be a waste of valuable learning time. The reality is, once you've got the basic idea down during a session, continuing to hammer away at it during the same session doesn't strengthen the kinds of long-term memory connections you want to have strengthened. Worse yet, focusing on one technique is a little like learning carpentry by only practicing with a hammer. After a while, you think you can fix anything by just bashing at it. Using a subsequent study session to repeat what you're trying to learn is just fine and often valuable. It can strengthen and deepen your chunked neural patterns. But be wary, repeating something you already know perfectly well is, face it, easy. It can also bring the illusion of competence that you've mastered the full range of material when you've actually only mastered the easy stuff. Instead, you want to balance your studies by deliberately focusing on what you find more difficult. This focusing on the more difficult material is called deliberate practice. It's often what makes the difference between a good student and a great student. All this is also related to a concept known as einstellung. In this phenomenon, your initial simple thought, an idea you already have in mind, or a neural pattern you've already developed and strengthened, may prevent a better idea or solution from being found. We saw this in the focused pinball picture, where your initial pinball thought went to the upper part of the brain, but the solution thought pattern was in the lower part. The crowded bumpers of the focused mode and the previous patterns you've built can create a sort of rut that prevents you from springing to a new place where the solution might be found. Incidentally, the German word Einstellung means mindset. Basically, you can remember Einstellung as installing a roadblock because of the way you were initially looking at something. This kind of wrong approach is especially easy to do in sports and science, not to mention other disciplines, because sometimes your initial intuition about what's happening or what you need to be doing is misleading. You have to unlearn your erroneous older ideas or approaches even while you're learning new ones. One significant mistake students sometimes make in learning is jumping into the water before they learn to swim. In other words, they blindly start working on homework without reading the textbook, attending lectures, viewing online lessons, or even speaking with someone knowledgeable. This is a recipe for sinking. It's like randomly allowing a thought to kind of pop off in the focus mode pinball machine without paying any real attention to where the solution truly lies. Understanding how to obtain real solutions is important in learning and in life. Mastering a new subject means learning not only the basic chunks, but also learning how to select and use different chunks. The best way to learn that is by practicing jumping back and forth between problems or situations that require different techniques or strategies. This is called interleaving. Once you have the basic idea of a technique down during your study session, sort of like learning to ride a bike with training wheels, start interleaving your practice with problems of different types, or different types of approaches, concepts, or procedures. Sometimes this can be a little tough to do. A given section in a book, for example, is often devoted to a specific technique. So when you flip to that section, you already know which technique you're going to be using. Still, do what you can to mix up your learning. In science and math in particular, it can help to look ahead at the more varied problem sets that are sometimes found at the end of chapters. Or you can deliberately try to make yourself occasionally pick out why some problems call for one technique as opposed to another. You want your brain to become used to the idea that just knowing how to use a particular concept, approach, or problem-solving technique isn't enough. You also need to know when to use it. Interleaving your studies, making it a point to review for a test, for example, by skipping around through problems in the different chapters and materials, can sometimes seem to make your learning a little more difficult, but in reality, it helps you learn more deeply. Interleaving is extraordinarily important. Although practice and repetition is important in helping build solid neural patterns to draw on, it's interleaving that starts building flexibility and creativity. It's where you leave the world of practice and repetition and begin thinking more independently. When you interleave within one subject or one discipline, you begin to develop your creative power within that discipline. When you interleave between several subjects or disciplines, you can more easily make interesting new connections between chunks in the different fields, which can enhance your creativity even further. Of course, it takes time to develop solid chunks of knowledge in different fields, so sometimes there's a trade-off. Developing expertise in several fields means you can bring very new ideas from one field to the other. But it can also mean that your expertise in one field or the other isn't quite as deep as that of the person who specializes in only one discipline. On the other hand, if you develop expertise in only one discipline, you may know it very deeply, but you may become more deeply entrenched in your familiar ways of thinking and not be able to handle new ideas. Philosopher of science Thomas Kuhn discovered that most paradigm shifts in science are brought about by either young people or people who were originally trained in a different discipline. They're not so easily trapped by einstellung, blocked thoughts due to their preceding training. And of course, there's the old saying that science progresses one funeral at a time as people entrenched in the old ways of looking at things die off. Finally, don't make the mistake of thinking that learning only occurs in the kinds of subjects you acquire from teachers or books. When you teach a child how to deal effectively with a bully, or you fix a leaky faucet, or you quickly pack a small suitcase for a business trip to Hong Kong, all of these illustrate the outcomes of important aspects of learning. Physicist Richard Feynman was inspired in his Nobel Prize-winning work by watching someone throw a dinner plate into the air in a cafeteria. And Mike Rowe of the television shows Dirty Jobs and Somebody's Gotta Do It shows how important and exciting learning can be in a variety of different non-academic disciplines. I'm Barbara Oakley. Thanks for learning about learning.